All right, we're back, and in this video we're going to be coding one of my favorite programs, which is the Fibonacci sequence, and we'll talk a little bit about the golden ratio from there. This stuff on nested control statements, evens, and odds, we'll get to those in later videos. So first of all, the Fibonacci sequence is a sequence of numbers in which any number in the sequence is the sum of the previous two numbers. Now, there's a lot of sequences that actually falls in this category. The Fibonacci sequence, it's actually very specific, because Fibonacci, this is named after an Italian gentleman, I believe, was looking at something like the reproduction rates of rabbits. And so he started with 1 and 1. Two rabbits reproduce, and in theory they start making more and more rabbits. You could start with 0 and 1 and get the same numbers. You could start with 1 and 1 and get the same numbers. I think 1 and 2 is the most relevant, so we'll start there. So I'm going to say that 1 and 2 are the first two digits in our sequence. And this is where we really start to see things take hold. I'm going to take 1 and 2, add those together, and we get 3. I'm going to take 2 and 3, add those together, we get 5. 3 and 5, we get 8. And we just keep going. This happens kind of infinitely. So we'll call any number a Fibonacci number if it appears in the Fibonacci sequence. We're going to write a program called Fibonacci that prompts the user to enter a number n, and then displays the first n Fibonacci numbers. So in this example, what do we got? 3, 6, 9. So if the user asks for the first 9 Fibonacci numbers, this is what they would get. This is their output. And I want it to look just like this. I want the commas and spaces. I even want the ellipses here at the end. We'll talk about that. I'm going to hop over to IntelliJ, where I'm going to make a new project by going to File, New, Project. We'll go next, next. I'm already in my principles folder, so we will make the Fibonacci project, and it'll create the Fibonacci subfolder. I'm going to expand my project folder, right-click on the SRC, and make a new Java class, which I'm calling Fibonacci. Okay, we're going to go ahead and plug in our main method. We're going to go ahead and implement scanner. And now I'm ready to actually get input from the user. And like always, I'm going to basically tell them what the program does. In advance, this program prints the first n Fibonacci numbers. And then I'm going to say, please enter a value for n. Hopefully you've watched the last video where I talked about the difference between print and print line. I'm going to make this bad boy a print so that when the user gives me their input, it appears right next to the message. And it just looks clean. Okay, so now we're actually ready to get the user input, which is going to be an integer, and I'm just going to call that in. All right, so I've implemented scanner. We're kind of ready to start looping. So in order for us to do the sequence, again, it doesn't matter if you do 0, 1, 1 and 1, 1 and 2. I'm going to use 1 and 2. You got to have two numbers to start with, period. Okay, so I'm going to create two variables, fib1, which I'm going to set to 1, and fib2, which I'm going to set to 2. These are our two starting points, and I'm making them variables because we're going to update them. We're going to update them over the course of our loop. Now, I'm ready to start looping. Kind of. I actually already have two Fibonacci numbers, so maybe I want to go ahead and print those off. Right? I'm going to go ahead and print the two numbers along with the comma and space. Right? So we have those two numbers. Let's go ahead and print them off. I'm going to use a print here. The reason I'm using a print is because I want to do the 1 comma space, 2 comma space, and then the next time I go to print, it's actually going to take place inside of my loop, and so I want it to appear on the same line. I don't want to use a print line. I want to use a print. I'm going to print fib1 along with a comma space, and I want to print fib2 along with a comma space. Now I have successfully calculated and printed or displayed the first two Fibonacci numbers. Now we're ready to start looping. I'm going to create a while loop. I'm going to plug in my syntax. So I know how many Fibonacci numbers I want. I've done 2 so far. So there's a couple of different ways that you could handle this. You could subtract 2 from n and then use n in the body of your loop. I think most people probably think just like counting. What do I mean? I'm going to plug in a counter variable, right? In theory, we're starting at 0. This is ultimately going to, and this is a good comment here, number of Fibonacci numbers processed so far. Right? In theory, we'd create I, our counter variable started at 0, but if this is going to represent the number of Fibonacci numbers processed so far, I technically have done 2. I've calculated 2, I've printed 2, so I'm going to start I at 2. And we'll say while, well, this is how many I've done, this is how many I want to do. While I is less than n. Again, there are so many ways to actually accomplish this. You could subtract 2 off n to accommodate for these 2, and then just say as long as n is like greater than 0. That would be kind of a decrementing route to go. Here I'm going an incrementing route. It's whatever. It's whatever. Okay, so let's think about this. Now we're actually getting into some meat here. I'm going to plug in a Fibonacci sequence here as a comment because I'm going to kind of refer to it. Why don't we just go ahead and do, what, 21, 34, and 55. Okay, so here's our example Fibonacci sequence. I've already done this. Right? We could even leave that as a comment. What we're going to do with this loop is calculate the next Fibonacci number and output it. But I plugged in this comment because I'm going to use it as a visual. What it's going to seem like we're doing is that we're just moving along this, kind of like a sliding scale. We're going to slide along the sequence. Notice that I am highlighting 2 numbers at a time because initially this is F1 and this is F2. But what we're going to do is kind of slide along this. Once this iteration, the first iteration finishes, I want F1 to be 2 and then F2 to be 3. And then the next iteration will slide along again, making F1 3, F2 5. Okay? So, let's update these numbers. Right? We've already processed 1 and 2. This is what I want. By the end of the iteration, I want F1 to be 2. I want F2, I'm talking about Fib1, Fib2, to be 3. First thing I'm going to do is update F2. Right now, this is where they're at. You know what? How about this? I'm going to update F2. All right, I want it to become 3. How do I get there? Take a look at the data that we have to work with. How can we get that? Well, I mean, the sequence is, this is what it is. It's the 2 numbers added together will give me the next number in the sequence. Right? So I'm going to take F1, F2. I'm going to add those together, and that is the new value for F2. Right now, F1 is 1. F2 is 2. That's going to be 3. That's the new value for F2. I'm effectively moving it to there. Now, some of you are big brain and kind of recognize if we were to just simply write this and make it look like this, well, that's the same thing as saying F2 is equal to F2 plus F1. It's F2 is becoming what it is plus something else. This follows a shorthand assignment operator. I'm going to leave this as a comment, but we could just simply replace this with F2 plus equals F1. You don't have to, but I'm just pointing out that you can. All right, so I've updated F2. It's now here. What I need is for F1 to go there. Oh. Right? So let's back that up. Here's my current state. I just updated F2. It's now here. F1 still has a value of 1. And what I want is for F1 to be 2. How do I do that? You could come up with like a temporary swapping variable situation, but mathematically the relationship is here. Since F2 is already updated and it's 3, I can use F2 and F1 to get what the new value of F1 should be, right? F1 should change. It should become simply F2 minus F1. Right? The current value of F2 is 3. Current value of F1 is 1. The new value for F1 will be 2. Right, that's what I just did. I just took those numbers and I slid them along that scale. Okay, something of note. This one we can't replace with a shorthand assignment operator, right? Because the shorthand assignment operator order does matter here, right? If I try to do F1 minus equals F2, that's the same thing as saying F1 is equal to F1 minus F2, right? The order here matters. So this stuff actually does not work. I need to leave that one like it is. But I have slid those along that scale. That's one iteration. I, in theory, produced one Fibonacci number. Let's actually print it off. I'm again going to use a print here because I want the new number and any subsequent numbers to all appear on the same line. So let's print off the new number. The new number in this case is F2, right? We updated it there. In fact, you could print it off on line 26. Like this print doesn't have to be here. It could be up a little bit sooner, but I'm going to print off F2 along with the comma space. Okay. Keep in mind, I is the number of Fibonacci numbers processed so far. I effectively had just processed one new Fibonacci number. So I'm going to do an I++, which, as you know, is equal to I plus 1, which is the same thing as I plus equals 1. Right? These three statements are all the same. So that's one iteration. Really that's kind of the whole thing. Let's take a look at what we got so far and see if what changes we need to make. Please enter a value for n. Let's do 9 to kind of go with our example. Right, this is what we got so far. That's looking really good, other than I need the final ... Right, after the loop is over, this is what we got. I effectively need the extra dots. I'm gonna do system.print. You can actually use print or print line here because we're effectively done. But I'm gonna print off the final dots, the ellipses. Exact same thing. A bit of a problem here, right? This doesn't look exactly like I want. Okay, some of you may be thinking, it's fine. But I really kind of want to hone on this idea. Take a moment, see if you can kind of rectify the situation and what's going on. But here's what I recommend. Whenever we process these first two Fibonacci numbers, do F1, F2, and then stop. Then, whenever we go to print off the new number, I'm going to put the comma and space up front instead. Seems like a minor change, but that's actually going to fix our program to give us exactly what we want, an output that looks just like this. I want the first 9 Fibonacci numbers. And there you have it. Again, this final print line could have easily just been a print, It's the end of our program, so it doesn't really matter that much. But what's cool about this is it scales, right? I could tell it I want 5 Fibonacci numbers. I could tell it I want 50 Fibonacci numbers. Somewhere in here, these numbers are going to break it because we're talking about, there it is. What happened there? We overflowed, right? I went from a positive number to a negative number. We hit the maximum value of an integer and then went beyond that. That's going to cause it to wrap back around to the negative values. And there we go. Okay, just a little bit more. I'm going to talk about the golden ratio stuff. So the golden ratio is a special number found by dividing a line into 2 parts. So the larger part divided by the smaller part is also equal to the whole length divided by the longer part. I never know what these things mean. I just kind of put them in as a meme. The golden ratio is famous because it appears naturally in the world in several places. I actually wrote an essay in my art history class talking about golden ratio in art because I was fascinated by this. So why don't we just talk, simply put, this is the golden ratio, 1 to 1.618. It's roughly like 2 to 3, right? So what we have here is a lot of golden rectangles. And then within those golden rectangles, there are rectangles that follow this ratio, right? Effectively, one side is 1. Let's take like this bigger square that I'm kind of going around here. Imagine that this side is 1. This longer side is effectively 1.618, right? 1 to 1.618. And then there's nothing but golden rectangles throughout this thing. Once you have those golden rectangles aligned, I'm doing a terrible job explaining this, by the way. Once you have those golden rectangles kind of aligned in this manner, you can inscribe a spiraling line. And that's where they get kind of this dimension from. And what this is saying, what people that kind of subscribe to this golden ratio idea, dictating the universe, is that the spacing on sunflower seeds effectively follow this line. It just turns out to be like the most efficient spacing for a sunflower. But it's in theory, you see it in a lot of things. Probably like one of the more common ones is looking at the dimensions on your body, right? The idea is that if the tip of my finger to the first knuckle is 1, then the knuckle to all the way here is 1.618, right? 1 to 1.618. And then you can, in theory, kind of follow that throughout your body. From the tips of my fingers to my wrist is 1. From there to my elbow is 1.618. That's the idea. And the descent of a falcon is supposed to be like something along this line. You can really dive deep in this and it gets borderline conspiracy theory. In my defense, I kind of just like it. But my paper was talking about how proportions, my paper in college was talking about how proportions are used in art. And there were some things that people were like, that's the golden ratio, like the Parthenon in Greece. And it turns out it's just not the case. Anyway, the reason why I'm even talking about the golden ratio is any sequence of numbers that follows this pattern, right, such as the Fibonacci sequence, is going to approach the golden ratio as the ratio between its numbers. Right? The difference between the numbers is going to approach this. Right? The Fibonacci sequence is part of that sequence, so we can actually use this to kind of calculate the golden ratio. Okay, here's what I'm going to do. I'm going to plug in a number. It doesn't really matter where. I guess as long as it's after F1 and F2. I'm going to create an integer which I'm going to call ratio. And all it simply is the ratio between the numbers. Right? We're talking like F2 divided by F1. That order may matter. We'll play with it. Okay. So looking at the numbers, you're going to tell right away, you're going to get 2. 2 divided by 1, that's 2. Cool. But as we update the numbers, right, we move them along that scale, it gets closer and closer and closer to the 1.16, whatever it is, the golden ratio. So after I've updated my F2, I've updated my F1, I can also update my ratio. Right? It's going to be F2 divided by F1. So with each iteration, I get a more and more updated ratio. You could print that off if you want to. What I really care about is the final one. What is the final value of that ratio? So after we print off our sequence, I'm going to print off ratio. I'm going to right click in free space and run this thing. One definitely ain't it, right? Because it should be 2 initially. What's happening here? You gotta be careful. Take a look. F2 is an integer. F1 is an integer. I have division between 2 integers. That's a problem because it can lead to truncation. The fix is for one of these things to be a double. To be consistent, I'm just going to make everything a double. There's other potential workarounds, but this is the easy one. Let's just use doubles. The space difference is not a lot. We just added, what, like 12 bytes? So we got doubles, which is a little bit ugly, but take a look at our ratio. What's cool about this is the more that I do, initially it's pretty bad, but the more iterations I do, the closer and closer the number gets. To the point where you see we got that 1.618. I think it's cool. It works for any sequence that you do this, where you just, the new number in the sequence is the sum of the old ones. And they actually talk about it in this number file video, which I recommend that you check out if you're interested in it. But they just come up with some numbers, and then he proves that as long as you follow a sequence in this manner, right, where you're getting a new number based on the addition of the previous 2 in the sequence, you're going to get a sequence that approaches the golden ratio. So go check that one out. Go check that one out, and I'll see you in the next one.